I love the quality of vintage tools, and I also love the look and the quality of a vintage car as well. So when the opportunity came up to use 3D printing to fix a vintage car, not just any vintage car, a 1978 Corvette, I jumped at it. This is the broken part, and it controls the signal and the high beams as well. And I love to print industrial parts, and I think this is where 3D printing is really so valuable. So I want to try and give it a go. For old cars, machines, tools, really anything that's old, parts aren't always available anymore. And if they are, they can be insanely expensive. And I also don't want to settle just for good enough. I'd like to make something even better than the original so that it not only looks really good, but it will never break again. And maybe the best part of all this is that these parts are going to be 100% designed in Canada and 100% 3D printed in Canada as well. So let's see what it's going to take to fix this Corvette and get it back on the road. So stick around. I'd love a Corvette, but I don't have one, unfortunately. The Corvette that this belongs to is my neighbor's son's, and it is also his first car, and it is an absolute beauty. They bought this, put a lot of work into it to get it working well, but then when they were test driving it recently, something broke deep down in the steering column. Well, not just one thing, two things broke. This plastic piece, and even deeper was this die cast bracket, which is not very common and costs a lot of money and still looks really cheap. My neighbor asked me if I could 3D print a replacement for him, and I've been using my GD+4 for a little while now, and I'm pretty confident that I can make replacement parts with that printer. I also have some engineering grade plastics that I can print with as well. But if this is going to be indestructible, I think we're going to need to go one step further. But first, we need to try and reproduce these parts in plastic so they work right. So these are all the parts that I have, and this one part I was going to try and 3D print, and I certainly could do that, but this one is available. This is about $14 or $15, so we can buy that online. But this one, on the other hand, I had a look, and my neighbor had a look, and this is available, maybe, for about $600 or so plus shipping, and who knows how long to get it. So I'm going to get this back together. All right, I'm not sure I can get this back together with that spring in there. There we go. And then we have this pin as well, which slides in there. And then we have this lever. So that is what we need to try and reproduce. Now, I don't actually need to make this part. I think this part probably is fine as it is, but I'm going to go ahead and make it anyway, just because it's a little bit mangled up and doesn't look that great. The first step is to model this in 3D, and I've done it just by carefully measuring everything with a set of calipers and then drawing it in Fusion 360. This part looks simple enough, but it's actually pretty intricate, and that's because it is die cast. It has some very slight draft angles, which makes taking accurate measurements more difficult. It did take some time, but I have a really good start, and because I want this to be precise and as little warpage as possible on the prints, I've also calibrated the filament to make sure that the parts end up the correct size, and it's even more important because I'm going to be printing this 100% solid. I'm going to be using my GD+4 with PLA carbon fiber. This is a small part, so warpage isn't really a problem here. So I have a couple little changes that I made, which was to add these little recesses in here that I missed on the first go. This one here was inside of this hole, and this actually would have been a pretty big mistake if I didn't test fit all these parts together, because I didn't see inside there. I was relying completely on my calipers. And my calipers were not seating in the right area. There's a step right inside that hole. I ended up drawing all of the little pins and the spring and the little cap as well, just to make sure I had everything and I knew what was going on. Okay, that's good. That feels good. Here's the pin that goes in there. This is not supposed to go all the way through. There's supposed to be a shoulder, but when I drilled this out, I went a little bit too far through that plastic. That sounds great, and it feels great as well. This looks really good, but I never actually saw how it operated, so I want to check with my neighbor to see if this is what it's supposed to do. Hey Tom, it's Mike. Just want to confirm that it's supposed to do this. So it stays in this position, and then you flick it and it stays in this position as well. I was also able to get that little tiny spring clip in there, so everything seems to be working perfectly. Let me know. Thanks. Well, it turns out that this is not how it should work. It's supposed to reset to the same original position. So after a few failed attempts with minor adjustments, I decided to 3D scan the original parts. Now in the past, parts this small were nearly impossible to scan with any accuracy on our phones, but now they allow the use of the macro lens. So I'll take some overall images for the general shape, and then I'll get in really close to any of the critical areas, making sure that I have really good lighting as well to make sure that they are very precise, because there is obviously something going on that I don't understand. With the scans, I was able to figure out the problem with this shape. When I first measured it, it looked like a flat surface meeting another flat with a fillet where they met. But that is not at all what this is. This is a very carefully engineered curved shape. This is the area that the spring-loaded guide rides along, and if this isn't right, it won't work correctly. So I've made some adjustments and reprinted it one last time to give it a try. So this is how it should work, just like that. Seems simple. I went ahead and I made an entirely new version. This is a completely 3D printable version, and the idea here is to see how truly strong a fully 3D printed version is, of course with the exception of the pin and the lever as well, and I also 3D printed a handle here too. Now I have a block here that I can grab, and it allows us to see how this pivots as well. It does not have the spring mechanism in there, but we'll put some force on here and see how much it can take before this piece breaks, and we'll also be able to see where it breaks too. So we'll do that near the end of the video. But this is not where I wanted to stop. What I wanted was an indestructible version, and to get something that's indestructible, or close to it, we need something made from metal. I don't have a metal 3D printer though, but I know a company that does, and that is the company that has made this video possible. That is Forge Labs. They work out of Canada and in the US as well. These parts were made in Canada. Thank you, Patrick, for helping me to make this video possible. So let's open this up, see what they look like. I have a few different options that I want to show you, and then we'll actually put this all together, and hopefully we'll be able to get all of these parts back into the Corvette and working again. Right away on the 316 stainless steel version, I noticed the level of detail Forge Labs was able to capture. Normally the text and any logos on this scale don't turn out that well, on my prints at least. This looks really good, and it also has quite a bit of heft to it. The detail on the aluminum version looks good as well, but I'd put it just a little bit behind the stainless steel with how crisp the text and logos are. Still really good though. As for the nylon part, you can see that it can't quite capture the same level of detail as either of the metals, but it is just a little bit better than what I'd expect to get in my shop. Made from metal, I have two versions. So I have a stainless steel version, which essentially is an exact reproduction of the original. As there's a little bit of deformation from the heating or sintering process for this part. So inside here, very little reinforcement. You can see all this material have been removed. When I did the aluminum version, I changed it a little bit to reinforce this area in here. So I filled this in. You can see this piece does not go all the way through. For the most part, pretty small changes. In here, I have a little fillet as well, right in this corner. And on this one, I left it just square like the original right in here. As far as the plastic 3D printed parts, I went even further, reinforced this area even more. I added a gusset into this area, rounded this corner here, rounded this corner, inside corner here as well. So this professionally done 3D printed version is going to be pretty strong, and it may actually be plenty good to do the job as well. It is much lighter than the original, but weight here doesn't really matter. One issue just to be aware of with small parts like this that are made with a powder bed is that some of these inside small areas will still have powder in them. You can see here. So I'll take these outside and use the air compressor to make sure that this is all cleaned out inside there. So we need to do a little bit of preparation on these metal parts. Now when I spoke to Patrick at Forge Labs, he said that they can do machining on their parts. They can also do polishing, but we both agreed that it's probably better not to show the parts that way. These are the parts as anybody would get them if they were just to order a 3D printed metal part, the standard finish. So it's the least expensive option. And then in your own shop, you can do whatever finishing you need to. And in my case, there's very minimal to do. First thing is to remove this little reinforcement piece, and to do that, I'm going to use my good old Dremel tool. I was going to try and ream these holes out in the drill press, but there doesn't seem to be any good way of holding this, so I think I'm just going to have to use the good old-fashioned drill. So my minimal experience here in working with stainless steel has not been that fun. This is not that easy to machine. It's really, really tough stuff. It does not like drill bits. Working with this aluminum is more like what you'd normally find. It's pretty easy to machine. A little bit gummy, I would say, which is pretty typical. So all that's left to do is put all this back together and give it a try. That works really well. I'll try the other plastic ones, but I may end up just leaving this one. So now just this little spring clip needs to be installed. Perfect. That's good. And then this should just be kind of a snug fit. Not too tight, not too loose. That's good, just like the original. And that, my friends, is it for the assembly. This needs to go into the Corvette now, but we have one more test to do. I wanted to do a brake test on this 3D print. So let's go ahead, we'll put the crane scale on here. I have it set to newtons. I have my slow-mo camera set up as well. I will pull it at the end of the lever. This is PPS carbon fiber filament. I can see it bending. Oh, my workbench is moving. Great. Okay. So it broke pretty much where we would expect it to break in this weak area, and it's not difficult to think of ways to reinforce this. So we had 61.7 newtons, 13.9 pounds, 6.3 kilograms, and the entire mechanism failed at this hinge point, which was kind of a weak spot, and that was 92.1 newtons, 20.7 pounds, 9.4 kilograms. So not too bad for this connection, not too fantastic for this one. It does make me wonder though how this one broke. Did it break because of the force applied here? I don't know if we'll ever really know. Anyways, we have the solution from stainless steel, and I think this is going to be an awesome long-term solution. All right, time to see if we can get this thing installed in the Corvette.
Like this.
Now it needs to pivot. It's not too bad with a bit of grease or oil.
Yeah, I'll lube it up really
Yeah, it's
good.
not bad.
And this clips back and forth. And I got to push all this stuff down, and this is your signal.
Yep.
So there's little switches in there, it'll click back and forth.
Yeah, it's crazy intricate.
Yep.
So we weren't able to get the car back on the road, and that's because there are probably 100 parts in that steering column, and it's been a little bit of time. We can't figure out exactly how everything goes back together, but the part was able to install. It seems to be working correctly. It needs to be oiled and greased up a little bit here and there. I'll have some videos soon with the Corvette all back in one piece and hopefully on the road, and when I do, I will make sure to link the video up there. So to finish off this video, I thought I would test out this 3D printed nylon part. So this is an SLS nylon part. Should technically be stronger than the one that I printed. And this is specifically designed to be 3D printed. There are some little details here and there that I added and some areas that I strengthened as well. Whew. Whew. It didn't even break, even though this is a pretty weak area. So is a plastic 3D printed part in place of the metal an option? Based off of this, I think it absolutely is, and that's pretty cool. So I might be using more of this material in the future as well. Unfortunately for my 3D print, didn't fare so well. If you're curious about the price, the nylon parts range from $13 Canadian, $9.50 US for the standard nylon, $30 Canadian, $21.50 US for the glass reinforced. The metal parts were a bit more pricey, of course. The aluminum bracket came in at $64, $46 US, and the 316 stainless steel version, $102.50 Canadian, $73.75 US. Still pretty reasonably priced, especially considering that they cost over $600 plus tax, and there's some shipping in there as well. Working with these metals and the plastics, these parts are not like FDM printed parts. They don't have those same weaknesses along the layer lines. This process works so well because I have the ability to prototype in my shop to make sure that everything works correctly before ordering it. Without that, I would not have been successful. I was also lucky that these parts didn't require much in the way of machining either, just a little bit of polishing to make sure that the rough surfaces didn't wear on any other parts over time, and a little bit of drilling as well. What I should have done is take the time from the start to 3D scan the parts. That would have saved me a lot of time and a few failed attempts as well. I find that 3D scanning on a white surface works the best with good lighting. When designing strong parts for 3D printing, I think of having to reinforce the weak areas, but when using professionally printed SLS or SLM parts, I don't need to do that anymore, which makes keeping the weight down and the cost down much easier as well. Forge Labs has an improved ordering interface coming, and it will allow accurate instant pricing, and they're also going to be adding options like polishing and anodizing as well. They produce a lot of parts for the aerospace and automotive industries, so the 3D printed parts need to be 100% solid, need to be durable, and they need to be lightweight as well. They can 3D print in titanium, two types of stainless steel, 316L and 17-4PH, maraging steel, and aluminum as well. I think this is the future of making replacement parts, and it would be ideal to make it at home, but for now, this is a really good process, and I love the fact that these were made in Canada as well. If you enjoy this type of content, consider subscribing and hitting that like button as well. It helps to support this channel. And if you're in the market for some 3D printed equipment and you want something that you know will last and work well, I have a very short list of quality products that I use in my shop on a regular basis. Thank you to each of my patrons for helping to support this channel and making videos like this possible. Also, thank you to Patrick at Forge Labs for helping to make this video possible as well. Take care, and we will see you on the next one. I have an aluminum version too, if for whatever reason you think that might be better.
This one is fine.
I think it'll be fine.
Doesn't break.
It's more than heavy duty wall. Is this also a Stingray? Is that what they call them?
Yeah.
Same kind of thing, right? Because that's that look.
Yeah. So there's an L48, which is the smaller engine. This one's got the larger engine, the L82. And then it's the anniversary one, right? So it's a 78. So it's the 25-year anniversary.
Oh. Wow, they were producing them for that long, eh, before?
Oh, yeah. Yeah, back in the 50s, right? 53 would be the first.
Holy cow. Yeah, I had no idea it went back that far.